And we're so very glad that they were able to join us today and be with us for this Farming and Ranching for the Bottom Line event, because I believe them as producers add a lot to the program. They're actually outdoing it. And in my estimation, going on right now, these two entities are doing it well and probably better than most. And totally pleased to have them with us today, and we're going to make this interactive. They're each going to give a short presentation, and then we'll turn it into a question and answer scenario. And I'd encourage everyone to try to participate and garner the knowledge that these individuals have, because again, they are a great resource. But with us today, starting out, is Derek and Tanis Axton. They're a third-generation owners of Axton Farms, which is a diversified grain farm near Minton, Saskatchewan. They have implemented innovative ideas to improve sustainability and profitability, including intercrops, companion crops, and cover crops, controlled traffic farming, and grazing as part of their farming system. They attend many workshops and conferences. They have met many farmers and scientists who taught them to change the way they looked at farming. And this has led to their journey towards soil health and regenerating their farmland. And what a journey it is, and in the way they describe it. But learning about soil biology and how soil function renewed their passion for farming and has improved the farm's productivity. As a result, they have reduced synthetic inputs, increased water retention, and have built up organic matter in their soils. In 2017, they were named the Outstanding Young Farmers for the Saskatchewan region. Both Derek and Tanis continue researching and sharing their passion for new ways of improving soil health. And we're very glad to have them here with us today. And at this time, I'll turn it over to Derek and Tanis. Thank you so much for being with us.
Thanks, Daryl. Really want to thank you and everyone there at the team there for putting this together and inviting us to come and share our farm story. I guess a lot of people are going to realize that our farm is just a big mixed up collection of other farms that we've been able to tour and sit in on and listen to over the past, almost 15 years now. So Tanis and I farm with our kids, Kate and Brock, and my dad, Herb, who's going to be 78 this year. I guess we're kind of third, sort of fourth generation, I guess. We've been on this place for over 100 years now. And we're really fortunate that we were able to, learn a lot of the things that we did so we can continue that for further generations. So this is sort of what our farm looked like last spring. Prior to the construction of our seed plant, I guess, which has sort of become the focus of our farm now. The focus now is going to be selling, I guess we like to say we use regenerative practices. I'm not 100% sure I'm a regenerative farmer, but we definitely use regenerative practices. And, we're trying to use that to help us to sell our grain as food products. So you can see here that we are literally farming up against where they stopped breaking land. The edge of our farm is against native prairie that goes on for 40 or 50 miles to the west of us. We're in a 12-inch rainfall zone. We're glacial till. We're actually in the Missouri-Coteau drainage area, so we're not really pothole country. And I really think this is a lot of why we ended up making changes. This is where great-grandpa got off the train. And, we're in pretty challenging terrain and low rainfall and those, fragile soils. And then that all sort of led to us needing, understanding the fact that we needed to make some changes if we wanted this thing to move on. Yeah, and that's, I guess, where I sort of met, I'd met Dr. Beck and then Gabe and then got to your farm and, the rest is sort of history. So this is what our farming system looks like. I guess I'm kind of a big believer that the whole is greater than the sum of its parts. That sort of line of thinking. this is, the things that we do that have all been, sort of taken from different farms that we've toured over the years and found that works in our system. And that was a big part of the learning curve was understanding context and how to take, ideas and those and, basic concepts and then adapt them to our farm. I was guilty off the bat of, coming home from Dr. Beck's and trying to grow corn, in 2007, and that didn't pan out so good. But understanding that we needed to have warm season grasses in our rotation was actually, that was the concept. So yeah, these are the parts. I mean, people usually ask, what is the most important thing? And I don't really feel like there really is anything that stands out for me other than the live roots. I mean, we definitely try to extend that growing season, mostly on the fall side. We know companion cropping's helped us with that, but yeah, and because we, in the context of talking about biology and the biological inoculants, it's one thing to put them in the soil, but those live roots will just help carry that through, through the fall and give that extended food source and help build carbon and all those things. So anyway, this is kind of what our farming system looks like. And yeah, so we're going to focus on the compost and the compost extracts and that whole side, and I'll let Tanis take over.
So we thought we'd take you quickly just through what our composting system looks like. It doesn't usually look the same 2 years in a row, but we've adapted and changed to make it work the best for us. We've went to using a TMR mixer to put all our ingredients in and mix them well. We found that makes a big difference to have good consistency when we're making our windrows. As far as products, we like to use local, mostly stuff that we already have and want to use up. So as you can see in the background, we've got the seed cleaning plant. So that provides us with a lot of byproducts, such as some grain screenings, hulls, different things that are higher in carbon. For nitrogen, we have used cow manure in the past. This year, we've went away from that as we're using up our neighbor's source and using the grain screenings that are higher in nitrogen as our nitrogen source. And it seemed to work really well. It froze up before I've had it able to have a good look at it, but it heated really well. So in that pile that we're making there, you've got grain screenings. We use flax bales, usually some hulls, and we also really like slough bales. We've always found that gives us quite a bump in protozoa into our compost. So that's always one thing we like to make sure we get in there. People talk about carbon to nitrogen ratio a lot. We do not check the carbon nitrogen ratio of all of our ingredients. A lot of what we do is trial and error. The more we do, we get a better idea. But from there, we just have to monitor, and if it's too high in carbon and doesn't seem to be heating, then we know we need to add something higher in nitrogen, and vice versa. If we can't get it to heat, then we need to add some more carbon. Next one. So the composting system we use is thermal composting. We like thermal because it allows us to get rid of any pathogens and the weed seeds, so that when we're spreading this compost back out onto the fields, it's something we don't have to worry about. So once a pile is made, it's monitored very closely, check the temperatures. We'd like it to get to 131 degrees on the inside for at least 3 days, or 150 degrees Fahrenheit for one. Once again, it just depends on what's in there and how fast it heats. So once that mill has been hot enough, long enough, we need to get out there and turn it. Also, we like to keep it at 50% moisture. So we found by making compost, we prefer to make it spring or fall because it's a lot easier to maintain that moisture in the piles and we have to add a lot less water. This past summer, we made a pile and it was windy and dry, and we just couldn't haul enough water to that pile to keep it at the right moisture. So we use a compost windrow turner, which allows us to move the inside, the hot inside, to the outside so it can cool off and doesn't get too hot. And then the outside is brought to the middle so that it can heat. So we like to Ideally, we like to have them turned about 3 times. Depends if they seem a little bit hotter, it'll take a few more times. But yeah, anything else? So the compost we can't make enough to cover all of our acres. So we'll usually pick the fields that we feel are most in need of a bit of a boost. We like to think of the compost as a biological inoculant or a probiotic to get back out to the soil. When we spread, we like to spread around 2 tons per acre. And because we can't get this across all of our acres, that's where we turn to making compost extract. So depending how many windrows we have made, I have a look at them under the microscope and usually pick our top 3 or 4 favorite so that we can get as much diversity as we can. We use these baskets, fill them with compost. They've got the air diffusers that go inside. And on the right, you'll see my big tank. We fill it with water and then put the baskets with the compost in. And basically, you just have the air and the water washing the biology off the compost and into the water. Because my baskets are quite small and my tank is quite big, we change the compost in those baskets usually 4 to 5 times. I'll use the microscope to check the extract and see if it looks like it's got enough diversity. And then once it looks good, we use this in furrow at seeding time. Anything else you want to say about that?
Mix it with minerals 1-to-1, 4 gallons an acre.
You can say that.
Yeah, so we mix this, like we have sort of a mixture of minerals and biological foods, I guess, for lack of a better term. And so we mix that with this at about 4 gallons an acre of each. So we wind up with about 8 gallons, which gives us, like, our one seeders on 10s and our other ones on 15s. But on the 10s, 8 gallons gives us a pretty nice consistent stream and furrow. So we kind of like that ratio. And then, like, one thing I guess Tanis didn't mention is, like, when we do pull out of this tank, we like to shut the air off about 10 or 15 minutes before we pull out and just let all the particles settle out. We do filter it through a 15 mesh filter, which is actually quite coarse. And then we like to mix those 2 components, the compost extract and the minerals, just as it goes to the field. And so we try to keep them mixed as little time as possible.
Yeah, so this tank is constantly aerated until, like Derek said, right before it goes out, because it really, one of those things that's another trial and error. There's too much floating around. If it allows to settle down, then we don't get as much into the pump. So before the extract goes out, I use the microscope to have a quick look at the extract. I don't do any counts. I basically am just looking for diversity. Is there protozoa, nematodes, fungi? I like to see a little bit of everything. And because we use the compost from the same piles, can kind of get it figured out in the spring. Okay, it's going to take 4 changes to get the right amount of diversity into this extract. And then I don't always have to be there to check every single load that goes out.
We normally have like an intern, in the springtime from, I guess, who knows where. It's been different every year. But that's generally someone who's interested in this stuff, and it really helps them get a grasp of, how to do it at scale. So it's been a really good fit. And once they learn that they need to change it every 3 times for every 500 gallons we take out, or whatever the math is, it works really well. So this has been a bit of a learning curve. Actually getting it into furrow, when Tanis took Elaine's course and we sort of came up with this idea of doing this compost extract in furrow, it sounded really good until we started trying to pump it through a nozzle type, I'm not even sure what you call it, but like a orifice type distribution system. And that was maybe the longest spring of my life. We were, multiple times a day cleaning things out, and we knew we needed to do it. It was just, we were doing it the wrong way. And I met a really friendly Australian fella down at a conference in Kansas, and I was talking about my problems, and he introduced me to peristaltic pumps, which I guess we call squeeze pumps. And we were able to source some of these out of Australia, and what a change. Now we can basically we're filtering it at 15 or 16 mesh, I guess, actually, which is pretty coarse. I mean, we've got pretty big things, and this stuff, it just distributes really, really easily. We actually intentionally go thicker with this than we did before, and I really felt it's allowed us to increase the quality of the product we're putting down and the accuracy, and they're trouble free. I think they're similar. There's John Blue and there's other ones up here, but these ones were kind of sort of made for the made to be hydraulic drive and made for our broadacre application, so they work really well. Yeah, I guess the benefits are that they're super simple, really low maintenance. They turn like 25 RPM. It's been a big help. So we run these on both of our seeders, and they've been very good. Go.
So I was just going to take a couple minutes to quickly talk about, what we call worm juice. We actually got this idea from Jay. We had seen it there, and we love it. Now I'm down to, I just have 3 of these totes, filled them with my compost, added worms, and then we feed the bins different things. A lot of our food waste goes in there, so we end up with, from the seeds, tomatoes and carrots, and you wouldn't believe what all start growing in there. And these totes are angled so that when they're watered, which mostly in the summer is by rain, but in the winter I'll water them. On the angle, then the water slowly filtrates or leachates through the compost, and we collect the liquid. So from there I take the liquid and I keep it in a barrel, not aerated. Within this liquid, there's very little life. It's more of a biostimulant than it is actual biology. Usually when I look at it, you'll see a little bit of bacteria, but bacteria is everywhere. So we use this worm juice, for lack of a better term, is a seed dressing in the spring. And we usually use about 8 liters per metric ton on the cereals. You can see on the right, we've got an old seed treater that we use, and it just coats the seeds. I wouldn't say they're wet, but they're definitely coated, kind of wet. And then we'll let them sit before we actually use the seed. And legumes, we use 5 liters per ton. And yeah, I think it's a fascinating system, because we're getting rid of our compost, our house compost. The worms seem really happy. The trick is I need to bring it in the winter. I pushed them to their limit this year as it got kind of cold. But we get them to the worm shop, and then starting January, I started watering and collecting so that I'll have enough liquid to coat all our seed this spring.
I think one thing that, Tanis, we should mention about the worm, we don't actually water it to rinse it. Like it's a slow leachate. Like it might be a couple of liters a day out of each container. So I mean, it takes darn near all year of collecting for us to get enough out of those 3 bins to do our seed for the farm of our size. But it seems to keep fine in those barrels. We just keep a lid on them, and it seems to keep fine.
Yeah, at first I was of the mindset that this is biology and I need to keep it aerated. So the first year I tried to keep it bubbled. And then we had Dr. Christine Jones at our farm, and she said, no, this is it's a biostimulant with all these signals in it. So don't worry about keeping it aerated, which is a lot easier to seal it in a barrel. So we look at it, more as, well, she'll talk about all the science if you listen to her. I'm not sure we always understand it, but it's amazing the difference that we've seen.
So these are some of the changes that we've seen. I guess really aggressive root growth, good sheathing. That the coleoptile is so small on that seed that I can barely hold on to it, and we've got root growth like that. And that's some of the changes that the things we've observed, and then that just continues, it seems, throughout the growing season. But you don't always have to have a microscope to see these things. I mean, you can make observations like this. You can obviously a shovel. I mean, if everybody has everybody should have a shovel. It's funny, I've actually become a little bit judgmental now. If I happen to go to a farm tour and someone doesn't take a shovel, then I really wonder if where their interests truly lie. So I guess maybe I got that from Jay and Dr. Beck and Gabe, obviously, and but yeah, I mean, I think the trick is just look. I mean, you got to start observing and watching, and we don't look for real specific changes. We just really are concerned about trends. Are we trending the right way? Is it getting better? Is it getting worse? Same with our rainfall infiltration tests. We just really want to make sure we're trending in the right direction. So something that we like to talk about that I don't honestly hear enough at most of these seminars is regeneration of community. That's been a big goal for us, and that's why that thing is standing behind us. Instead of us spending our winters vacationing, we spend it adding value to our product and employing people. Will Harris was a big motivation for me. I thought he's super cool. I love what he's doing down there. And it just made us think, like, what can we be doing? Because I listen to a lot of these presentations, and most guys are really super livestock focused, and we aren't. We use livestock, but that definitely isn't our focus. And so we're going to add value to our grains. We've got 3 full-time employees plus our family, which for a grain farm our size is that's a lot more help than most guys our size would have. We're just in the process of hiring a 4th employee. I can see by fall we're going to need a couple of more, so that's the kind of growth that we're really excited about. My dad's 78 and he's excited to be a part of it still. So, I mean, that's a lot of fun. That's what gets us up in the morning, I think, and the rest of it is great. And we're proud of what we do, but if we can get our town going again, that's a big deal for us. So yeah, I guess that in short, that's it for us. Thanks very much again for inviting us, and yeah, I look forward to any questions you may have.
Chris is a 5th generation producer. As I mentioned, located in Shenandoah, Iowa. He first gained an appreciation of and understanding of the soil conservation from his grandfather. Since then, he has been in continuous learning mode and looks to apply what he learns to his Fremont County acres. Chris works on the farm with his wife Kay and his 3 children. When it comes to soil health, Chris is a major proponent of cover crops, and I think you'll hear that in his talk today. Whether it's cereal, rye, oats, barley, flax, and more, he says cover crops can have a powerful impact on the living structures that lurk beneath the ground. Over the years, rebuilding the soil through cover crops, earthworms return, as does the activation and enrichment of bacteria and protozoa through the stretching roots of the living plants growing within the bean stubble or decaying corn stalks. Erosion and nutrient runoff has also been curtailed because of the existing vegetation, along with increasing water infiltration as the soil is held in place through the strength of the plant's root structure. At this time, we'll turn it over to Chris, and again, so glad to have you with us today, Chris, and eager to what you have to say. Eager to hear for what you have to say. Thank you.
You bet. Well, thank you, and welcome everybody today, and it's a pleasure to be here. Like I say, my wife and I, we farm down here in southwest Iowa, the very southwest corner, next Missouri, Kansas, and Nebraska. So I'm a 5th generation farmer down here, and doing a lot in cover crops. Essentially, we were doing some cover crops clear back in the mid 80s and some mob grazing back then, but over the time, we got away from it. And then, 10, 12 years ago, started hearing about soil health, and my light bulb went off. It's like, oh, that's what I was seeing back there. And so I jumped in full board and been doing a lot of the basic cover crops, but also doing a lot of interseeding, just a lot of different aspects of it, some relay cropping. But what I'm kind of doing now and what I want to talk about, kind of just a practical way, how I'm bringing, some biology, restoring that back into our land, since we've kind of degraded land There's land, with excessive tillage. And just some of the chemistry we've used on the land, our biology has kind of gone away, and we focused on the chemistry. So I wanted to, focus on the biology and kind of restore that in our land. So
again, we have Chris Teachout with us from Shenandoah, Iowa, and he's going to take us through his journey and how he's bringing life back to his farm. And thank you, Chris, for being with us again. Take it away.
You bet. Well, yeah, we had a little technical difficulty here getting the screen up and stuff. But anyway, I'll kind of talk through my presentation. Basically, my title slide is, growing your own biology, and how to do this so we can kind of restore some of the biology in our soils. And so basically, I kind of, I've been all around and have seen a lot of different meetings and immersed myself with a lot of information. And, even, Dr. Johnson, made the Johnson Sioux bioreactor. And then I kind of modeled this somewhat after this, but kind of made it my version. And he uses the mesh and the wire so, the sides can breathe. But what I've done, I've taken a tote, 275-gallon tote, and I'm kind of just using what I have. And basically, we take the bars off the top, and we cut the top plastic, so we open it up, kind of like in Tanis's, in the worm juice bins. That's how they kind of look. So we take the top off of that. Then in the very bottom of that tote, we are taking a wooden pallet, and you got to cut off about 11 inches or so of it, so that'll fit down in the bottom of the tote. And then we need some aeration tubes, and we want this to be a static aeration. And why we do that, because we're trying to go after a more fungal dominated compost, and to make a super inoculant out of this. So we take some the sewer drainage pipes that have some holes drilled in the sides of those, and we stick those down into the slots in the pallet in the bottom of that tote. And then there's been a couple different ways of putting in the base layer. We've done it with wafers of straw for that very base layer on top of that pallet in the very bottom. And then if you have access to, some landscaping fabric, you can put that down there, and that works a lot better, what I've experienced. And so then the different food sources and inputs that I put into this, we first kind of start out with a real, good carbon source. We put in some straw in that. And then we kind of lasagna layer this and kind of mix these as we go. And then we also use some wood chips. Now, if you don't have access to wood chips, I have used, pine chips, but I'd rather not use the pine chips. I'd rather use some soft white wood like willows or cottonwood, and have those for another carbon source. And they're a real good fungal food too. And then I add some other different things in there just to, I want to stimulate as much biology in different ways, and getting some different, signaling things, the quorum sensing, by putting a lot of diversity in this. So we'll put in some kelp, and in a tote, at 3 or 4 pounds of kelp will really work. Then we also use some dry fish powder, and it's a real good, fungal food too, but it gives us some real good protein in there to help, break down some of the wood chips and the straw. Then we also had some old biochar, some inoculated biochar, and like I say, it only takes a little bit of that to put in there and get the thing stimulated. Then I also try to bring in some native biology. And the native biology was we had old stock cow loafing shed that had some old dry manure in it. So some of that has some native biology in it. So we wanted to, throw some of that in there in the mix also. Then we to get kind of our C to N ratio, the carbon to nitrogen ratio, we're trying to take, some of the browns, the carbons, and then we add some greens into that. So we've put some fresh grass and clover chopped up. So like I say, we're lasagna layering this. And then we want to get into putting in some fungal duff. And if you go into a rugged timber, a lot of times the leaf litter and the first couple of inches there, if you'll see a lot of saprophytic fungal activity there of breaking down and recycling the nutrients. So if you take some of this and inoculate your bioreactor with a couple pounds of this, it really stimulates it. And then what we're trying to do, I sure wish my pictures were up, but anyway, this is a picture kind of a forest floor, and it shows fungal threads or fungal fruiting bodies coming up, and it's showing the leaves breaking down. So we're starting from there, and that's what we want to kind of emulate, look at nature and see how it's doing. So, and then in our bioreactor, after we've started it, after we put all these materials in there, one of the things I do is I flood the whole thing with rainwater. And that's why I did the IBC, so we could contain that rainwater in there. And I let it set for 36 to 48 hours. Then we are draining that liquid out of the bottom valve of the toad. And we don't waste that. We'll put that on another compost pile or just start another one. But anyway, if we soak it that long, we'll get all these things up to about that 70-80% moisture where it needs to be to activate. When Dr. Johnson's doing it, he's putting material in wheelbarrow and soaking it and putting it in. And I guess as a kid, I kind of scooped enough crap, so I didn't want to do that. So that's kind of why I came up with flooding this. And then we pull that water off there. And then within a few days, we're up to 135, 140 degrees. And it'll be there for about 4 or 5 days. Then I put data loggers in here where the temperature then just goes on down, kind of a linear slope on down. And after it goes through the thermal phase, then we add our livestock. After it's gone through that heating phase, then we'll put in some red wigglers, and 100 of them will work just fine, and you dump them in there, and within a minute or two, they're disappeared down into this material. So this thing is the bioreactor is gonna take about a year to really get some good results out of it. And anyway, we also kind of look under a microscope and start to see all the different nematodes, protozoa, ciliates, and it's amazing, and all the bacteria, and just it's amazing what you're growing in here. Anyway, after we had this over a year, then we sent it in. It was some really nice, rich brown breakdown, and we sent it off to Earth Fort to get a report on this, because what we're trying to do is take our soils, which are highly bacterial now, with the farming practices that we've had, we want to get to a 1-to-1 fungal to bacterial ratio out there in our fields, in broadacre crops. That's about where we should be. And we're right now, a lot of fields are very highly bacterial, especially if you're in a tillage mode, you're going to be highly bacterial. So fungal does not like disturbance, but it likes having the rooting systems out there and the diversity of rootings out there. So when we sent this test off, like I say, our goal was to get a highly fungal compost and, also have some, a good degree of the bacteria and the other components of it. When we got it back, the green bars on this chart were way above, they were maxed out to the high range on both fungal and bacterial issues. What was in there. And so we made this compost, and it's 4.7 to 1 fungal to bacteria. So we kind of met our goals, and I've shown this around to people that have looked at, are buying different compost, and beginner's luck or whatever, but this is what we kind of set out to do, and we came up with this. Really pleased with it. And then, so we're using that as, sometimes I've used it straight away, almost like a peat-based inoculant, throw it in the seed mixer when we're mixing cover crop seed, and we can put it out that way, or else we'll do an extract. And I've got a cone bottom tea brewer, but I use it to pull out the extract and extract all the components of this compost, so we can apply it in furrow to our seed. And we've played around with this, before we're doing any data testing on it. We're seeing some, very good results of the healthy plants, the root structure, and everything. Just, we start to see these things, that really improve. So now, going forward, we're going to get the data to it and do a lot more strip trials. But at first, we have to kind of throw something out there and see, what we can observe, going down this road. So going on down, some of the next things that we're doing some capturing some lactobacillus, with a rice water wash, and we're trying to make some other biostimulants that way. We're taking some of that lactose serum, stabilizing that with molasses, and then we're also using that. And then we start to make a fermented hydrolysate. And it's kind of just making your own biofertilizers. And what we're trying to do with like a hydrolysate under this fermentation is to pull out a lot of different amino acids and a lot of plant signaling here. So that's kind of where we're headed, and just kind of having fun, playing in this. So that kind of concludes it. And sorry about not having the pictures in there, but anyway, we made it.
Exactly, Chris, and thank you so much for improvising and getting through that. We wanted the real live versions of everyone today, and some of those things that come with that we have to deal with. But again, a great talk, Chris. And Derek and Tanis, and if the questions are out there, please go into the chat and start asking them. But just a little review of each of the presentations. Derek started out by saying, and this is where his great grandpa got off the train, and I've got a little side story on that. I kind of feel the same way. You wonder why they got off the train there. My 13-year-old daughter asked me that the other day when it was 46 below windshield, and she said, "Why do you think great grandpa stopped here?" And I said, generally it's because Oswalds were being better known for being tough than smart. So anyway, he talked about the whole farm system, and he talked about the holes, and that struck a nerve with me right away too, because he's thinking in holes, ecosystem function. He talked about his root growth and having a shovel and mentors and all the things that go along there. Can you answer the question, Derek or Tanis? You were talking about putting 8 liters per metric ton down on your small grains. Is that per acre or?
Oh yeah. So on the seed dressing, we do 8 liters per metric ton, so 2,200 pounds. On the cereals, mostly because that's about all they can absorb. So, you can maybe go to 9, but when we leave it sit for about a half an hour or 40 minutes and then move it again, because if you don't, it could set up. And the same, that's why we do a lower rate, like 5 liters per ton on the on peas, lentils, chickpeas, beans, that sort of thing, just because that's about all they can absorb. It gets kind of yucky if you put much more than that on. I guess we've experimented a little bit with doing it twice, but didn't really see any difference. So we just kind of went to the max one pass and left it at that.
Thank you for that. Another question, Tanis had talked about they're putting their compost on fields that they feel need a boost. Talk about your soil testing regime. How do you know those fields need a boost? What constitutes needing a boost?
Okay. I guess I'm answering this one.
Oh, well.
I guess we do look, but generally that stuff we've been buying some land, I guess, that's next to us, and generally that's the stuff that needs it, and so that's usually where we focus it, is on stuff we've taken on, because the bulk of the land that we've been buying has been farmed, conventionally, not good in conventional sense, I guess, but we know it's biologically lacking, so it's kind of one of the first things we want to do with it. I guess and the 2 tons an acre that we apply of the dry compost is simply because that's all our equipment is capable of going to as far as low. We would do less if we could, but anything below 2 tons, we have a bunning spreader with a spinner deck, and anything below that it just doesn't do a consistent job. So we're actually looking for something better, because we feel we'd be farther ahead to spread more acres with less amounts if we could.
Thank you for that. Moving on to Chris. Chris talked about growing his own biology, right? And I think if you talk to the Axtons, they would probably say the same thing. They're growing their own biology. John Kemp this morning talked about there being different components to the soil, but we know very little about the biology component. Most of the tests and things we do are based on the physical or chemical. Chris, can you talk about that, and then talk about the native biology? What inspired you to go get that?
Well, I guess what inspired me to get it. Just my mind is always spinning. With all this information, the input, then it just stands to reason. Well, part of it is like native biology, like the cow manure from an old loafing shed, is I've seen, all these different yield maps of farms. And a lot of times when you look at that yield map, there'll be this little square or this area of that farm that just stands out. It's got a super yield on it. And if you go back in history or ask the person that's farming it, what was there, it's like, oh, that's where the old farmstead used to be. And it's showing, and it has tremendous growth there because it had the livestock, it had that biology up around the farmstead. So that's one of the things is, if you're doing this and want to collect some of your own native biology, go to those spots on your map that are super yielders, that you can see that old farmstead. And so inoculate some of that. I just want all the chances of putting things in here that, for our goals, trying to make a very, very diverse, on the fungal end of it, going into a timber. I spend a lot of time, walking in the woods, and I like looking down at it. And when you observe that, how the nutrient cycling, how that fungal component is really breaking down the leaves, and it's breaking down. The leaf litter is very thin come spring or summer, because all the microbes are working on that. So I want to maybe have some of those. So I want to have all the chances of putting different things, different food sources to get, like the different signaling, just like on the worm juice, same thing. It's not just all the biology. There's some other things in there that are triggers, and they set some of these things into motion. And so that's I just want, when everybody spoke about diversity in cover crops and all that. So that's why I wanted to do it, this bioreactor.
Thank you, Chris, for that answer. Another thing that you had mentioned that I thought of, you mentioned looking at nature and see what it is doing, and the Axtons can respond to this as well. In a lot of our current ag production model, we tend to not do what nature's doing, to be blunt, but here you're saying you look at nature and what it's doing. How do we move forward with that mindset in the agricultural community?
I guess the mindset is, you got to get the spade out, and you got to use your senses and to get out there and really observe what's going on, because it's a natural process out there. But if we leave it all up to just a chemistry set, that's probably what the end result, what you're going to have, and you're going to have some other issues and stuff. So instead of trying to fix our problems with chemistry, we have to start going back and ask the why. Well, why are we using that? Well, because we've got a disease. Well, why do you have that disease? Well, the plants aren't quite healthy enough. Well, why aren't they? We're throwing all this chemistry at them, but why don't we look at, like I say, walk in the prairies, walk in the timber, and see how some of these things function. So we have to really observe and trying to get, and we're trying to teach a lot of even young agronomists some of these principles and to look at this. So it's an uphill battle, but get out there and observe.
I had one question come in over the chat here, I think that could relate. It says, this question's for Chris. What are you using for a protein source for making your hydrolysate? I believe
okay.
It's, do you understand?
Yeah.
Okay, thank you, Chris.
Yeah, the hydrolysate, what we're using in that, you could use some meat sources, but I'll kind of shy away from that. And so I used, some soybean meal, some kelp meal, and some crab meal in there. So when you take those components, each one of those components can deliver a lot of real good amino acids. So there again, we're looking at diversity, and we've got to do some lab work on that to see where we're at on that, what our amino acids are coming out of that.
Thank you, Chris. One of the things I'd like, and then we'll move to Derek and Tanis for a question or two, but Chris, if you could expound on your use of cover crops and what they've done for you, again, looking at nature and looking how diverse nature is, and of course using diverse cover crops, what that's done for you and what it can do.
Yeah, like I say, we've been intensive into cover crops. We're in corn and soybeans, a lot of times you're limited to zero rye. So we've done that a lot, but we try to maximize the carbon input from that by planting our soybeans early into that, letting them grow together for about 40 days before we terminate the rye. So then the rye's at anthesis and we maximize our carbon. But when we add diversity in a corn-soybean rotation, we've had to do some interseeding of some multi-species cover crops. And that's worked, and we've got some really good results on being able to reduce nitrogen down. By use of cover crops and these different rooting systems, we've been doing our, one of the first tests that, I really like to look at on if you're looking at somebody's farm and to identify how healthy it is. We go out there with a spade, but also the water infiltration test, where you pound the ring in there and pour the water in the ring and time it. Well, we did our first one, about 3-4 years ago, and that first inch went in about 2 minutes and 30 seconds. Which is good because there's a lot of the first 1 inch on a lot of farms it'll sit there for 30, 40, sometimes an hour for that rain to go, or that water to go in. This summer we did a test, and after we've been using all these different practices, we started pouring the water in there, and we had 5 inches of water that we put in that ring in a total less than 2 minutes. So our soil is just really being spongy. You can see that when you go out and observe these with a spade. You can see the crumb structure. You can see the pore space. It's opening up. Our soils are really nice and cushy, and we're more resilient to drought. So when we get a heavier rainfall, like a 3-inch rainfall, we got 3 inches of rain. When a lot of times next door or so, you'll see the chocolate shake coming off the land, and there goes all your nutrients and everything. And 3-inch rain, you only got half inch, maybe an inch out of that. So being effective on that, that's where long term all these things put together really pay off.
Thank you for that, Chris. Appreciate that. Derek and Tanis, a couple things about your compost. They came over the chat. One of them, and I think I can put it into one question. One of them related to why thermal compost, and is there a different type of compost that you could be using? And then one gentleman asked, are there any downfalls to using the windrows for composting? Using an example of what if one part of the windrow needs to be turned and another one doesn't. So if you could expound a little on that, please.
Sure. Yeah, this might take a little bit to answer it all.
No, that's fine.
Yeah, so on different types of compost, we've looked at lots. We had Jerry Gillespie and Christine Jones here, I guess 2 summers ago, when we did the sort of inoculated facultative compost, where it's a covered oxygen limited method, which we really like and we really like to do more of. We can actually talk with Jerry about doing sort of a modified version of that, where we would turn it once. We use a lot of grain screenings in our compost, so there's weed seeds and things that we don't necessarily want to be hauling back out to the fields. So that's why we've really focused on thermal. Our number one dislike with thermal is our losses. It's generally about 40% of weight from what we haul into what we haul out. We are going to start experimenting with adding gypsum in the spring to our new windrows. We've got some new findings, and I'd love someone to tell me if I'm wrong, but we're going to add some gypsum so we can actually kind of complex the ammonia so we don't lose it nearly as much. And also apparently it helps with total losses. So that's something new. And we we need the sulfur, right? I think that's one of the things we're going to struggle to get away from. Yeah. So that's, I guess, why we do those. And the thermal just guarantees us that we get the weed seed kill and any pathogens, because we do use some, I don't know, rotten green isn't really maybe right, but there's, sometimes when we clean, there might be a little bit of fusarium, or there might be a little bit of things in our screenings, right? Stuff we don't want in our finished grain that's going to be in that, and we want to make sure we get those pathogens killed. So that's the biggest reason for thermal. And because we're doing 2,000 to 3,000, 4,000 tons a year, it's super windy here, where the covered method is it stresses me out a bit to have that many covers, and actually to have them stay there all summer. But I'm going to let Tanis touch on that.
Well, actually, I was going to move on to the whole consistency. And when we first started making our windrows, that is a major problem we found. I'd check one end of the windrow, and it needed to be turned at this end, but at the other end, it didn't need to be. So that's where we went to the TMR mixer, and we put all the ingredients in at the same time, make a full pass of the windrow, fill it up again, another full pass, so that the windrow itself is consistent, basically the same materials all throughout. And now we've found the heating to be a lot more consistent, so that we're not, because with some windrow turners you can pick up and do just parts of the windrow, but ours you can't. So we needed that ability to keep it consistent all the way through.
And you can really see that. She had a slide that actually, one frosty morning, like how they were steaming just consistent from one end to the other. And that's what huge change we saw when we went to the TMR style windrow applications to before, when you're hauling out of a manure pack, you can, some of it's pure manure and some of it has more straw, and it just, you get huge variations, and it was almost impossible to manage, where this seemed to fix that problem.
Thank you for that answer. This is a question for both of you that came in, and it relates to do you see that you will have a need to continue to apply the compost team, worm juice, etc. in the long term, or do you feel that, or are your biological conditions again improving to a point where it could become self-sustaining? And if each of you could touch on that, I'd appreciate it.
Yeah, I guess I'll go jump in here first. Yeah, I think, we can re-inoculate these soils, get them going, and get the machine basically running. And I think then we can back off, and then we can kind of maybe do some testing down the road. But I think once we get it going and inoculated, we won't have to do it every year, or we could maybe skip a couple years, once you have a system really going. But that's just kind of my opinion on that. So.
Derek? Janice?
We were just actually chatting about that, and I think it might be a split decision here. I guess partly because the way our farm is now, and we're always going to have compost ingredients here that we're always going to be composting. I mean, and we're looking, and it's amazing what people will bring you once they find out you're composting, from heated grain to rotten bales to, and drop it in your yard. So, because they don't know what else to do with it. So we're always going to be composting. So I think, and I'd love to think that we're going to get there someday, but it really feels like maybe it's a bit of a never-ending journey, especially you got to understand where we are. Like, this is some pretty tough ground, and it was degraded to the point of almost no return. And so I think everything we can do to keep adding it back, and really most of it's pretty simple for us to do. And yeah, I mean, ideally, sure, we'll get there someday, but it's going to be quite a while, I think, for us.
Yeah.
Thank you for that. That was a great question. And finally, before we end the panel today, Derek and Tanis, excuse me, and Chris, you can touch on this as well. But Derek, you ended your talk talking about community regeneration, and Will Harris. And I've had the opportunity to meet Will. He is the original dude and a fine Southern gentleman. And I'm sure you were as enamored with him as I was. But what is the number one thing we can do to improve our community growth and regeneration? I know it's a tough, loaded question, but I know you guys are up for the task for it, and that's why I wanted to end with it, and maybe discuss a little bit about that. And Chris, you could certainly chime in as well.
I'm going to attempt to answer that question. Thanks very much for that. That's a dandy. I think we're just going to keep trying to do more of what we're doing. I mean, when I look at agriculture and, and I think about back, I guess, I think a lot about export, right? How we the whole thing has been set up to export our grain and export our jobs and export our kids, and export our businesses out of our communities. So that's a lot of what we're trying to do. We're trying to do more value added, on our farm, and we're actually seeing more growth that way. Maybe locally, maybe I'm just optimistic, but there's a lot of things we can be doing, on our farms that we don't have to put on a truck to have it happen, as far as, cleaning some grain or maybe harvesting some beef or whatever that is that can happen on farm. And it's amazing how you reach sort of this tipping point. And I've noticed it in communities that have some sort of significant business, whether it be an air drill manufacturer or or a large enough, processing facility that it creates a hub. And then once that thing reaches a tipping point, then it just sort of feeds on itself, and that's, I guess that's where we're trying to get to, is somewhere along that line. It's going to take some time, but you got to start somewhere.
Chris, do you want to weigh in on that?
Sure, I'll give it a try. Yeah, I guess what it takes is, some opportunity. And I think through this pandemic, we've kind of shown that people really kind of starting to question where our food is coming from. And so the local food movement, was beginning, and then pandemic hit. I think, this can really stimulate, some of the change, for small food producers and, grass-fed beef and just a lot of things that can bring a community kind of back together, because that's how it was when I grew up. Everybody had livestock and all, and the community was very vibrant, and had a few manufacturing places in our town, but it slowly kind of withered down. I think there is opportunity for young people, and I think us that have been in it a while, it's just like Derek, hiring on more people. That's kind of the grounds roots of where community kind of starts. So yeah, it's a tough one, and some places are going to be, not make it. But I think if we, as older producers or so, give some opportunities to some young farmers or to help somebody out, get started.
Thank you. Thank you so much today, panel. Again, I appreciate the opportunity. Our team appreciates that you took the time to be with us today. I appreciate the opportunity to moderate such a distinguished panel, and thank you so much. So now we're going to take a break until 1 o'clock, and we'll be bringing John Kempf back to talk about water use efficiency, which I believe will be very, very interesting. And again, I hope you enjoyed the morning, and look forward to being with you this afternoon and resuming again at 1 o'clock. So thank you.